Everyone. My name is Vida, and I'm education lead at MetricsDAO. Today we have a very special workshop together with Silver, the co-founder of Playgrounds. Playgrounds is a leading data solutions company specializing in blockchain data analytics. And today we have a very exciting workshop, which is part of a workshop series. And today we actually are going to be looking into the growing interest in curve finance, and particularly the recent CRV-USD launch. So today, in the first workshop, we will be delving into curve governance, and we'll be using Subgrounds and other relevant sources and addressing some really interesting questions. So very excited for this workshop today. And Summer is going to be sharing with us um, the tooling of Subgrounds and how we can use it to analyze this recent launch. So if you have any questions during the workshop today, do drop them in the chat, and we'll be answering them over the course of this workshop. So thank you everyone for joining, and let's kick this off.
Thank you, Vida. So, GM everybody, my name is Christoph, but you might know me as Stouffer on Discord and elsewhere. I'm the co-founder and CTO of Playgrounds. And as Vida said, today we'll be diving into curve governance and using our tool Subgrounds to analyze different voting behaviors and other things related to curve governance. So, quickly going over what we'll discuss today. I'll give a brief introduction of what Playgrounds is, what we do as a company, then briefly go over what subgraphs and subgrounds are, because these are pretty important for the workshop. Quickly do a survey of what Curve is as a protocol and how their governance is structured, and then we'll dive right into the workshop itself. So analyzing Curve governance. There's a lot of stuff to cover, so I'll try to go quickly over the slides here. So what is Playgrounds? Well, Playgrounds is a data solutions company that provides easy and reliable tools for accessing blockchain data through subgraphs. If you've heard of the graph protocol, then you're probably familiar with subgraphs. Subgraphs are essentially standardized ways to index and model blockchain data. And once the blockchain data is extracted from the blockchain, it's available via GraphQL API. So you can think from the point of view of data analysis, subgraphs are essentially GraphQL APIs that you can query to get modeled data. And the reasons why we think subgraphs are important for data analytics is because they standardize the process, as I've mentioned, but they're also very scalable, right? Thanks to the graphs architecture and its network of indexers, subgraphs you can create as many subgraphs as you want to analyze different parts of a given protocol or even different parts of the blockchain. And they're also very flexible, right? They allow you to define any sort of transformation that you would like to do, as well as define how you want the data to be served via the GraphQL endpoint. However, in terms of data analysis, just having a GraphQL endpoint is not very useful. Right? And this is where Playgrounds comes in. Whereas the graph will take care of, collecting the data, storing it, transforming it, and making it available through the GraphQL endpoint. Playgrounds provides tooling to essentially access that data through the endpoint and make it available in a Python environment in which you can use all the data analytics tool that you would usually use to do your data analysis work. So for instance, pandas or plotly, Jupyter notebooks, and the likes. And the tool to do this is called Subgrounds. So this is kind of a simplified representation of where Subgrounds fits in the data story. On the left-hand side here, you have the graph, where the raw blockchain data is indexed by the graph and its network of indexers, and then modeled into subgraphs Usually you'll have a subgraph for each protocol, but some protocols will have multiple subgraphs, each tackling a different part of the protocol, as is the case for Curve, as we'll see. And once you have your subgraphs, this is where Subgrounds comes in, where the library allows you to load, query, and then process the data from subgraphs. So that you can then export it to a data frame, a CSV file, or a visualization. So why should you use Subgrounds? Well, first of all, it's easy to use, and it uses standardized tooling that is very popular in the data science environment, like Python. And it's also very customizable because it's open source and it's built in a modularized way such that it's easy to add functionality to it. It also saves time. Subgrounds takes care of a lot of the nitty gritty of data, of like getting your data into your environment, such as paginating, formatting the JSON data into data frames, and interacting with GraphQL, right? So with Subgrounds, you don't even need to write raw GraphQL, as we will see. And Subgrounds already integrates with different analytics libraries that are available in the Python ecosystem, such as Plotly and Pandas, so that you can quickly integrate Subgrounds into your existing environment if you're a Python data scientist. So this workshop is designed to be a little bit more advanced than like your typical introduction. So I'll skip over things like installing Subgrounds and Python. There are some links for that in the slides, which will be posted in the MetricsDAO Discord server. But to really get the most out of this workshop, you should be familiar with Python and some data analytics libraries like Pandas and Plotly. And even though you don't need to be able to write complex GraphQL queries, you should at least be able to read a GraphQL schema to be able to know what entities and what kind of data is available on a given API. In terms of the dependencies that we'll be using for this workshop, Subgrounds requires Python 3.10 and above. We'll be using the latest version of Subgrounds, which is 1.5, with the Plotly extra dependency. And we'll be using IPY kernel and NB format for being able to run Jupyter notebooks inside VS Code. As I said, these slides will be posted in the MetricsDAO Discord server. So here are tons of links that will be very useful for you to get started with Subgrounds and analyzing data on the graph network. All right, before we dive into the analysis, let's briefly talk about Curve Finance. Curve Finance is a decentralized exchange protocol that was started in 2020. So they're kind of like OG DeFi. If people remember like the beginning of DeFi summer in 2020, they were there at the start, right? They didn't have a token yet, but that comes later. And in terms of how the decentralized exchange works, they use an automated market maker model, similar to what you would find in Uniswap V1 and V2, SushiSwap and Balancer. But unlike those protocols, Podmo asking, yes, Podmo, those links, the slides will be posted in the Discord. So the links are in the slide. But yeah, going back to Curve here, unlike Uniswap and SushiSwap, their model is optimized for assets that have nominally the same value. So pools of different stable coins, which should all be worth $1 or €1 or one of any currency they represent. Pools containing only wrapped Bitcoin derivatives, right? So like Rent BTC, WBTC, and the likes. And their model is optimized for such liquidity pools, and it makes it really efficient from a trading point of view. In terms of how liquidity is incentivized on Curve, Curve developed this concept of gauges, where essentially each liquidity pool that the protocol wants to incentivize is given a gauge with a certain weight. And then based on the weight of all the gauges on the protocol, this determines how much of the Curve emissions liquidity providers for each pool will get. So there's a fixed amount of Curve that's emitted every block, and then that is distributed to the pools according to the weights of the gauges. In terms of governance, this is fairly similar to um, a lot of other protocols out there, with a few notable exceptions. So the biggest is that, unlike most protocols where you can just vote if you have the token of the protocol, with Curve you need to lock your. Oops, I realize I made a typo here. It's supposed to be CRV. You have to lock your CRV tokens in order to vote. So they call it vote escrowed curve, or V curve. And the idea here is that you can only lock, um, or rather, the duration for which you will lock your curve will determine how much voting power you get out of your tokens. So the longer you lock your tokens into the protocol, the more voting power you get, which, in theory should incentivize voters to make better decisions and to take the long-term health of the protocol into consideration. It also, makes it so someone can't just like lock a bunch of curve, vote on something, and then unlock it immediately afterwards. They have to stay in the protocol. The governance is also entirely on-chain. They used to have some on-chain voting via the Snapshot platform, but this has been discontinued. Although those old votes can still be accessed via the Snapshot API. We will not be covering those because there's a lot of noise on Snapshot. And in terms of what you'll find, when we start looking at the different proposals during this workshops, you'll see that a lot of the proposals fall into two categories. So either, a modification of a protocol parameter, so like the fee percentage, or adding a new pool, or, modifying the factory contract, things like that. Or, you'll have proposals that either create gauges for a pool or change the weight of a given gauge. So kind of adjusting how, the liquidity incentives are structured. So in terms of the research questions we'll try to answer during this workshop, and again, I'll try to go, try to cover most of them, but in case we run out of time, the notebook and the slides will be available in the Discord. So you'll be able to continue the workshop on your own. But yeah, first of all, we'll be looking at curve voting behavior. So, when it comes to individual proposals, what's the participation rate? Are they mostly one-sided, right? Is it like everybody always votes the same, or is there some actual like debate or like controversial proposals? We'll then look at how proposals impact protocol metrics. So, are there key proposals that stand out, which seem to have had like an important impact on TVL or volume or fees, things like that. We'll also look at individual voter activity. So, given the address of a user, what types of actions did they do within the DAO? Did they create proposals? Did they vote? Did they lock some CRV? And then kind of like analyze how that tracks with the amount of V curve they hold, right? Did they lock a ton of CRV before an important vote to be able to participate, or is it more like they participate in an ad hoc way? And finally, if we have time, we'll go over a breakdown of a proposal. So given a proposal, how is voting distributed? Who's voting for it? Who's for? Who's against? What's the size of their V curve holding? All right. So now that the slides are over, let's get down to some analytics. Yeah, and feel free to ask questions, or if you want me to clarify anything in the chat, I can read those on my screen. So I'll be answering those as they come. So I've set up here a simple environment with Subgrounds pre-installed. For the actual installation instruction, I would recommend reading our docs. The link to our docs is in the slides, but you can also find them if you go to docs.playgrounds.network, and you'll have like a guide on how to install Subgrounds. So once you have your environment with Subgrounds installed and all your dependencies set up, and your notebook set up, the first thing you want to do is import the Subgrounds object. And after that's done, you want to initialize the Subgrounds object. And the point of doing this is that the subgrounds object here serves as kind of like the singleton through which you will interact with the graph. So whether you will be querying data or loading a subgraph, you will always be reusing that object. And once you have your subgraphs object initialized, you can actually start loading subgraphs into your environment. I'll quickly go over how to find subgraphs before we dive deeper into the code here. So if you go to thegraph.com, you'll get to their landing page, and under the product tab, you'll see the Graph Explorer here and the hosted service. We'll be mostly using the hosted service for this workshop because that is sort of like the free version of the Graph network. But eventually, all subgraphs will be migrated to this other Graph Explorer here. But I won't go into many details about like the difference between both. From our point of view, it doesn't really matter for now. So you go to the hosted service explorer, and then you can start searching for subgraphs. So for instance, if I'm looking for curve, I'll see that there's a ton of curve subgraphs here. If I type curve voting, there's none. Curve governance. Yeah, the search is a bit wonky sometimes here, but essentially, once you find a random subgraph here, say you click on a subgraph, you look at the different entities that are available by going through the different types here. There's a documentation explorer on the side. You can look at the different fields and the different entities that are part of the subgraph. So in this case, this subgraph contains tokens, which represent like ERC20 tokens, and each token will have an ID, a name, a symbol, decimals, different fields, right? Likewise, for in this particular subgraph, you can get daily financial snapshots of the protocol, right, which contain like TVL, daily volume, and things like that. So once you've found a subgraph that you're interested in analyzing from Python, you can query that. You can copy that query link here by clicking this little button here, and you can just paste it. Subgraph. You just paste it into this function here, load subgraph, and this will essentially grab the schema of the subgraph, so like all the type definitions, and it will create this object that you will then be able to use to construct queries to fetch the data. How do you actually fetch data once you have loaded a subgraph into your environment? Well, query construction is done with something called field paths. So field paths are essentially data selections starting from the subgraph object, right? So we have our subgraph here. We want to query data. Then, if I look at all the fields that are part of the query object, you can see that, there's accounts, deposits, events, liquidity pools, right? Note that this was a curve finance subgraph. So, you'll see the gauges here that I was talking about. So you can create a field path, essentially selecting the data that you want. So for instance, we want the accounts. And then for each account, maybe we want the ID, right? And once you have the field path, you can then use the Subgrounds object with the method query df. Essentially means query a data frame. And then you can give it the field path here in a list. And this will query account IDs in the subgraph. Obviously, if you want to get more fields than simply just the ID, you can add more fields to that list here in query df. So here we have our Counts field path. Say I want the ID. I want the, go back to our subgraph here. Not only has ID. Let's go for token. There it is. This tokens. Symbol. Decimals. And then we get a data frame which contains, the token IDs, the token symbols, and the token decimals. So this is kind of like the very basic way to query data in Subgrounds. But I'll encourage you to go and read the docs, and we have other tutorials as well that we hosted as part of the MetricsDAO workshop series. So those links are also in the slides. But going back to the goal of this workshop here, analyzing curve voting, there's this interesting subgraph here, actually created by the convex community, which captures all of the different activity that goes on the curve DAO in terms of governance. So we'll be using this subgraph as kind of our main data source for this workshop. So the first thing we want to do is load the subgraph. Once we have it, let me also open up the Explorer. Oops. So we can see the different entities that are available here. So we're looking for proposals, right? And we can see that this particular subgraph has a proposal entity, which contains essentially the data we're interested in, right? So when the proposal occurred, the metadata of the proposal, right? So what's the title of the proposal? What does it involve? As well as like votes for and against. So we'll be mainly using this proposal entity. Potmo is asking, what's the best way to see the attributes of the subgraph object? Yeah, so there's various ways you can do that. I think like the graph has a pretty good UI to do so. You can just go to the page of a given subgraph and see the different entities here on the right-hand side panel. Amir is asking, does load subgraph use the compression method to get the data, or does it not need to do so? So load subgraph actually makes an introspection query to the subgraph so that it can understand like, what sort of data is available on the subgraph, and then also use that information to validate your queries before you make them, right? So going back to our little small example here, if I try to query a field that doesn't exist, like potato, right? Subgrounds will give you an error, say like, hey, there's no field potato for the token entity. And what's cool about this is that you actually get the error before you make your query. So you're not making useless round trips, essentially. All right, so your voting subgraph has a proposals entity, which we want to query to get some historical data about proposals. So what we'll do is we'll first create a proposals field path, which essentially just be querying the proposals from the curve voting subgraph. And here, this is a good example of how Subgrounds allows you to set different arguments, right? So we'll grab the first 1,000 proposals, we'll order them by the proposal start date, and we'll ask it to put them in descending order. Then in terms of the actual fields we want to create from the proposals, we will we'll grab the ID just to be able to reference them at a later point. We'll also grab the start date to know when the proposal was created. We'll grab the metadata so that we know what the proposal is about. And we'll grab the votes for and against, as well as the total vote count. Let me do this right here. The proposals time. Proposal count. Votes for. And votes against. We'll run this query. It gives us a data frame, which is displayed right here. And you can see that we have our first data frame for proposals. So we have the ID, the start timestamp of the proposal, how many people voted, the number of votes for the proposal, and then the number of votes against as well. But this information is kind of very raw, right? And there's not a lot of stuff that we can do with it. So allow me to introduce you to another concept, another very powerful concept from Subgrounds called synthetic fields. And synthetic fields are essentially transformations that you can make on top of the GraphQL schema of the subgraph that are applied essentially anytime you query the subgraph. Right? So if some of you are coming from the SQL world, you can think of synthetic fields like SQL views, right? Where you have your original table with a given schema, and then you can create views on top of that table, right? By defining transformations on the different columns. So this is what we'll do here to kind of refine our data frame and make it more interesting. So the first thing we'll do is, just get a more readable format for the start date so that we don't have to deal with Unix timestamps. So to do so, we'll first import synthetic fields. And then what we'll do is that we'll define a new field on the proposal entity of the curve voting subgraph called datetime. We'll make it equal to the datetime of the timestamp of that other field. Because we know that this other field, the start date, is a Unix timestamp, we can use a pre-built synthetic field to essentially do a mapping from Unix timestamp to a Python datetime object. So, if we query the data again, but instead of using the start date here, we'll use our new datetime synthetic field, we will get a data frame with nice human readable dates. Let me take a second to read the chat here. Okay, yeah, so Amir is asking, do you have to specify all the fields? You don't have to. This is when you want like more granular data. If you just, say query df and give it like curve voting dot query dot proposals, if you just stop there, Subgrounds will automatically select everything. So, the proposal ID, proposal FF is like every field that's available on the entity. But then you end up with really large tables that are kind of hard to parse. So, okay, so we have our first synthetic field that formats the timestamp into something more human readable. Next thing that we want to do here, to answer our initial questions about voting behavior, is to essentially get the ratio of people who voted for and against different proposals. So to do this, we can create a new synthetic field called vote ratio, which is essentially the proportion of votes for a proposal divided by the total number of votes. And notice here that you can use field paths with Python arithmetic operators to create synthetic fields. So this new synthetic field here, vote ratio, will be exactly that equation. But note that like at this point, no data is being queried either, right? This is just defining a transformation that will be applied at query time when you're querying the data frame. Yeah, and so yeah, we have our vote ratio here. We can add that to our data frame as well. This. And we have a new column here called proposals vote ratio. So already we're getting something a bit more interesting, right? We can see that like for a lot of proposals, the ratio seems to be just, 1 or 100%, meaning that everyone voted for a given proposal. But you see that other proposals are not so clear cut. And we'll dive deeper into the numbers here in a second. I'll just quickly add a few other synthetic fields and kind of quickly go over them. So another one that I kind of came up with myself, and I'm sure that would make political scientists roll over in their graves, but essentially I created some sort of controversy index where essentially it calculates how far the voting ratio for a given proposal is from 50-50. The closer the vote ratio is to 50-50, the higher the controversy index, and it's scaled between 0 and 1. So that will be useful for detecting, which proposals spark the most divided voting, essentially. And I'll quickly add a few other synthetic fields here. This one here is essentially just the support required, which is the number of V-curve that has to vote for a proposal for it to pass. That number is represented in terms of number of actual V-curve units. So it has like 18 decimals, but we'll just divide it by 10 to the power to the 18th so that we can just get like a nice round number or human readable number. Also quickly add 2 other synthetic fields here. The participation rate, which is the total votes, so votes against and for divided by the total supply of V-curve at the time of the proposal. So that gives you an idea of how much of the total V-curve voted. And also, again, adjusting the minimum accepted quorum amount divided by 10 to the power 18th, so it's more human readable. Okay, so let's add those fields to our data frame. So we have a controversy. Let's forward. Participation. And the required quorum. So you can kind of divide all the fields here into categories, right? Where these are related to kind of like how the vote went down, right? Who voted for, against, was it controversial, etc. How much support the proposal needed to pass. And then you have these 3 fields, which are related more to participation, right? So how many people voted, what was the participation rate, etc. So let's query this data frame here and render it. And well, we have all the different columns that we created using synthetic fields here. So now we can actually start extracting some insights from those historical proposals. We also see that we have like 393 total proposals on Curve. The first thing that is a good thing to do when you have a data frame with data is to just describe that data. The pandas library comes with a very useful method called describe, where you can essentially just ask it will automatically calculate like some interesting statistics in your data frame. So already, we see that the power of our synthetic fields combined with the pandas library gives us some interesting insights into curve voting. So for instance, we see that the average vote count for all the proposals is 20. So on average, only 20 individual wallets are voting per proposal, with a max. There's one proposal that got like a lot of individual votes here with 822, but most seem to be much lower. We also see that the average participation rate is around 45% of the total V curve. So, that means that on average, less than half of the total V curve is actually voting for the different proposals, which is interesting. It would be, some exercise for the audience here would be to compare that number to a similar number for other protocols, right? See if the V curve approach really does boost participation. We also see that when we look at our controversy index here, most proposals don't seem to be very controversial, right? With a fairly low controversy index of 0.03, but we see that there's a max value of 98.98, so at least one proposal has been very controversial. And looking at the vote ratio as well, the average vote ratio is 0.91. So essentially, it seems that most votes are pretty one-sided in favor of the proposal. So these are some interesting statistics on their own, but let's try to find like what the outliers are. Which proposal actually got a controversy index of 0.98. Well, to do this, this is where we start going more into the pandas side of this workshop, where Subgrounds was useful to create some synthetic fields, grab the data from the graph, and then output a nice data frame. But once you have your data frame, you can always modify it and play around with it using the pandas library itself. All right, so let's create a new variables called controversial proposals. And this new data frame here will essentially just be the existing proposals data frame that we will sort according to that proposals controversy column. And I have to set the ascending flag to false so that we sort it in descending order. And then we will just grab the head of the data frame. So that just grabs the top, the first 10 rows after sorting it. So we'll do this, and then we'll just display it. Here we have our top 10 most controversial proposals. And I actually looked into this before, so I know what the answer is, but I thought it was pretty funny. Oh, wait. Okay, I realized I forgot to add the metadata to our query, so I'm going to quickly do that here. Metadata. I mean, by metadata here, we have the actual proposal in plain text. So getting our controversial proposals again. The most controversial proposal in the history of the Curve DAO was whether or not to add a gauge for the Frax UST liquidity pool, which, with hindsight is pretty funny knowing what happened to UST, right? And it makes sense that there was a lot of debate because even before the DPEG, I know that USD was somewhat controversial. And yeah, that had a controversy index of 0.98, which corresponds to a 50.5% voting ratio, right? So there's actually more people who voted for the proposal to add a gauge to the pool than against. But thankfully for Curve, they have a minimum threshold of 51% for a proposal to pass. So this proposal did not pass. But you can imagine what would have happened if a gauge was added to that pool, and then UST would have become a much greater percentage of the total liquidity on Curve. Yes, no, that's correct. That's V curve amounts, so not people. But we can still see the number of individual votes here, which 41% of individual wallets voted for that proposal, or like, so still more than the average of 20. And we see that 65% of the total V curve voted for that in the context of that proposal. Now, so yeah, we figured out what was the most controversial proposal ever. We can also look at like a few others. We can see here that there was one to add a withdrawal field. Yeah, 41 people control have the V curve. What's interesting about Curve is that as a protocol too, is that convex is kind of built on top of it. So, you know, a lot of individual Curve holders actually delegate their votes via convex. But yeah, some other controversial proposals, adding a flat fee to withdrawals from pools, increasing the current fee, things like that, right? You would expect those to spark a fair amount of debate in the community. And I'm realizing that we are quickly running out of time, so I'll try to go fast with the rest of the analysis. So we figured out which proposals were the most controversial. Let's quickly look at which proposals gathered the most participation. So first we'll get the proposals where, well, the most individual voters. There were the most individual voters. So we just changed the field by which we're sorting the data frame here. And here we can see that the highest, the proposal that got the most individual votes was whether or not to whitelist a convex protocol, which makes a lot of sense, right? Because all these individual voters were probably very happy about convex being whitelisted on Curve. That way they wouldn't have to vote individually ever again. Yeah, and then we can see that a lot of other votes, right, have to do with whitelisting for the most proposals with individual votes, or for the proposals with the most individual votes, which makes sense, right? Because like every time you have a protocol that wants to be whitelisted, then the users of that protocol will want to vote for that proposal. Let's quickly check which proposal got the most participation in terms of V-curve. You can see that the top one here got 83% of total V-curve voting for that proposal. And that was something to do with a new pool implementation, looks like a coin pool implementation, and lots of other gauge related proposals. So pretty interesting stuff by itself. All right, so that kind of wraps up the first part of our workshop here. So like, you know, analyzing the individual proposals. I don't think I'll have time to cover all the questions I wanted to cover, but I'll quickly go over the next batch, which is, you know, voting and the protocol metrics. So how does, you know, proposals affect protocol metrics? How can we visualize this with subgrounds and Plotly and Pandas? So the subgraph we were using up until then focused really like only on the DAO itself, right? So it had things like proposals, individual votes, as well as user information like the size of their V curve holding and what they voted for. But it doesn't really have any financial data like the TVL or the volume over time or the fees over time, which is kind of what we want to compare or contrast with the proposals here. So what we'll do is we will essentially load a second subgraph. This one is Messari's curve subgraph for the Ethereum deployment, which contains a lot of the financial information we'll need to answer our second batch of questions. And I'll be using only the Ethereum data here because, well, it's the most liquid one, and I'm trying to keep the workshop scope to a manageable point here. But it's a good exercise to try and combine the data from Ethereum with data from other chains, right, and kind of do the same analysis here. All right. So we've loaded our subgraph. Second thing we want to do, we'll actually be making plots here and charts. So one nice thing about Subgrounds is that it comes with essentially wrappers and adapters for Plotly. If some of you are not familiar with Plotly, Plotly is essentially a Python visualization library, a data visualization. And the wrappers that Subgrounds provides makes it easy to essentially build charts very quickly using field paths. The same way it was easy to construct a data frame using field paths. Now we'll be able to construct charts using field paths. So let's load those dependencies and create our first chart. So we'll start with just plotting the TVL for curve over time. So we'll create a new figure. We need to pass it our Subgrounds singleton object here so that the figure is able to fetch the data when it's generated. And then we'll give it traces. Traces are essentially the data sets that will be plotted on this figure and how they will be plotted. So in this case, we want a scatter plot of the TVL over time. So scatter, we'll specify first we'll get our daily metrics field path, financials, daily snapshot, first 1000, ordered by timestamp. We're going to create a synthetic field really quickly to, again, get to the timestamp in a more human-readable format. So this, okay, we have our field path here. So we'll plot the TVL over time with the x-axis set to the date time, y-axis set to the TVL. Correct. The name, and then render it inside a Jupyter notebook. You actually want to just, once you have your object here, your figure object, this is like the wrapped figure from Subgrounds, but to actually plot the figure, you want to add the underlying figure here. So run this. I think there's a lot of data for this figure, so it might take a few seconds. Oh, there you go. All right, so we have our TVL over time for curve. Now let's try to essentially see how that TVL has evolved with proposals over time. So what I'll quickly do here is, we already defined like our proposal field paths back here. So I'll just grab this down. And then I'll add a second trace here to our figure, another scatter plot, where X will be the proposals take time, Y will be the to the participation rate. And we'll set the mode to markers so it only displays the dots and doesn't try to plot a line between the proposals. But if we render this, we'll get something that looks a little odd here because Plotly is actually trying to fit both data sets onto the same y-axis, which and participation is a number between 0 and 1, right? Well, as like the main y-axis here is the TVL, so calculated in billions of dollars. So all the proposals are kind of like stuck at the bottom. But already we can see we can kind of start plotting like the see how different proposals will map to the TVL, right? And we can even go further and labels here, set the labels to the metadata of the proposals, right? So that when we plot this, oops, oh, sorry, the text. So you can actually get like the proposal text when you hover over one of the proposals. And just to show you kind of what's possible with Plotly, there's a lot of stuff that you can customize about the charts. Here, I'll just copy like a big blob because I don't have a lot of time. But if we add a layout property here with a different values here, that basically tells Plotly to draw the 2 time series on different axes, right? So the axis. So that way, proposals will not look all squished to the bottom. And this is here. So we get something that looks a bit messy, but where you have on the y-axis you have both the TVL over time and the proposal participation. So the higher the dot, the most participation there was for a proposal, and you can kind of like see line up proposals with the TVL. Yeah, I know that we're almost at the hour here, so stop for now. There's more things that I had prepared for this workshop, but I'll be posting the Jupyter notebook in the MetricsDAO Discord server. So for those who want to see the rest of the workshop, I can kind of give a little preview.
Amazing. Thank you so much for the workshop. And I just wanted to remind you as well that this workshop is part of a series of 2 workshops. And we're actually going to have another workshop with playgrounds on the 30th of May. So I'm also going to post a link here in the chat, and ensure to attend this workshop because it's going to be a great continuation of what we have learned today. Is there anything you can tell us about what people can expect from the second workshop?
Yes, actually. So with the recent launch, partly like what motivated us to tackle Curve in this workshop series is that Curve just launched their own stablecoin. And at the time of preparing for this first workshop, there wasn't a lot of data available regarding the new stablecoin. But the hope is that by the time of the second workshop, we'll have almost a month worth of data tracking the growth of that new stablecoin. So the tentative topic of the next workshop will be Curve USD the first month. But that kind of depends on the availability of the data on the graph and via Subgraph. So stay tuned for more updates, but it will be related to Curve again.
Amazing, amazing. And in the case people have any questions in between the two workshops, what would be a good way to connect with you and with Subgrounds?
So the best way is to join our Discord. I will post the invite link. Maybe someone on my team can do it. So I don't think I can post in the chat, but I'll send the Discord link in the MetricsDAO Discord server.
Yeah, I just shared the Discord link in the YouTube chat, so it's there.
Awesome.
But we'll also share it on our MetricsDAO Discord too.
Yeah, so come to our Discord. Come drop by and say hi. We have Subgrounds office hours that we call Subgrounds and Chill every Friday from 3 to 5 Eastern time. So this is a place where you can, drop by very relaxed, ask any Subgrounds questions that you might have, or just hang out with the team. Yeah, and apart from that, we're also working on some other exciting projects that will soon be made public. So stay tuned for those updates as well.
Amazing, amazing. Excited to hear those updates. And before we finish, is there anything else you'd like to share with us?
Well, I think hopefully this has convinced you to give Subgrounds and Subgraphs a try for your analytics work. I know this was a very condensed workshop because there was a lot of stuff I wanted to cover, but the point was to show how powerful this tool set can become once you get used to it. So hopefully, I've convinced a few of you to give it a try.
Amazing. Yeah, this was an incredibly exciting workshop. I know people learned a lot about subgrounds, about um, Curve, and also increase their analytics skills. So it's been really great. And thank you so much for leading the workshop. And for everyone who's attended, like do sure to register to the second workshop, and the link was shared in the chat so that we can continue learning. Um, yeah, and thank you everyone for attending. And as Sachi just said in the chat, do ensure to give a follow on Twitter to Playgrounds to ensure that you are keeping up with everything that's happening in their community and with their product. And also, I'm going to be sharing the Twitter link here in the chat. So thank you everyone for attending today.
Yeah, and thanks. Thank you, Vida and MetricsDAO, for hosting me as well. It was a great pleasure to be here today.